Hello my students, your physics teacher Hassan Darwish with you. This is video 2 of the series videos about angular momentum. You remember in video 1 we talked about the angular momentum of a particle, and I gave you the general definition of the angular momentum of a particle as sigma equal r cross product with vector p, where r is the position vector of the particle and p the linear momentum of the particle. You know this is a vector in general, and this vector sigma is perpendicular to both r and p, okay? But we said also in the last video we are going to confine our study only to circular trajectories, means a curve which lies in a plane. Clear? So our definition of the angular momentum is confined to this simple rule: sigma equal I theta prime, where I is the moment of inertia of the particle and theta prime represent the angular velocity. And also this sigma, as I said, could be a positive number and a negative number, depends on whether the particle is moving in the previously chosen direction or opposite to this positive direction, okay? And also the SI unit of sigma is kilogram meter squared per second. Clear? Kilogram meter squared per second due to this rule. We also solved an example about how to apply the rule of angular momentum to a single particle. Now let's consider system of particles, okay? In the case of discrete system, means separated system of particles, then what is the total angular momentum of this system of particles? For example, let's consider the planets of our solar system turning around the sun. You know that each planet, like Neptune, is considered as a particle, right? And the whole planets represent or constitute a system of particles moving around the sun, okay? So what is the total linear momentum of the whole planets around an axis passing through the sun or around the sun? So it is sigma 1 plus sigma 2 plus sigma plus sigma n, means sigma of Earth plus sigma of Neptune plus sigma of Mars, etc. Okay? This is for a system of n-particles, discrete system. We call it discrete system because the particles are separated. Now in the case of rigid body turning around the sun, around an axis, this is a rigid body. This rigid body moves around the axis delta, okay? Like for example a disk moving around its axis, like the fan moving around its axis, like a sphere for example, or a rod. So this is a rigid body. You know the meaning of rigid body, means solid body. Distance between any two particles remain the same. And also you know that for a rigid body, every particle of the rigid body has the same angular velocity theta prime and angular acceleration theta w prime as any other particle. Clear? I mean all the particles of this rigid system have the same theta prime and the same theta w prime. So what is the angular momentum of this rigid body? Like this. So sigma equal I theta prime. Looks like that of a particle, okay? But what's the difference here? The difference here is that I represent the moment of inertia of the rigid system. Clear? So it is always given. I is always given. Because if this rigid body is a disk, then I is half mr squared. If it is a rod where the axis passing through its midpoint, it is ml squared over 3 over 12, etc. Okay, so I is given for the rigid body. Let's, for example, do an application about this rule, a direct application. We have here two particles, m1 and m2, okay, say any two planets, of masses 6 kilogram and 4 kilogram, move with speed v1 and v2 along circular trajectories, choosing the sense of motion of m1 as positive sense. He said, look here, m1, this is, choose this sense of motion, as he said, as the positive sense of motion. Okay, this is positive, means the clockwise is chosen as positive, not anti-clockwise. Calculate the angular momentum of the system of particles, referring to the rule sigma of the system, call it as equals sigma 1 plus sigma 2, right? Because we have only two particles, m1 and m2, but you know that angular momentum of a particle is I theta prime, so this is I1 theta prime 1 plus I2 theta prime 2. Okay, I want you to verify that I1 theta prime 1 is only m1 r1 v1, and here minus, so let me write it here, minus y minus, because m2 is moving opposite to the positive sense, so I prefer to write it here minus. So minus m2 r2 v2, right? So if you do the calculation, I will leave it for you, you will get the answer minus 24 kilogram meter squared per second. Okay, so put it here, per second. Notice here the angular momentum of this system is negative, and no problem with this, okay, because sigma is algebraic quantity. Okay, this is enough for this video. See you in the next video. Take care. Bye bye.